because how many ways are there to solve math?
Many!
Your life homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
Good afternoon and welcome to Count on Us. I'm Shari Sternberg.
I'm Miss Shirey.
And we are excited to be here with you. We're excited to be here to help you with your math homework, and we're excited to throw some challenges out to you. Let's tell them how they can reach us.
All right, all you need to do is get on the phone, call 301-772-0080. That's
You know,
all
I did
need to do.
this, and I bet you they have no idea what that means when I do this.
Oh, no.
When they dial the telephone.
Rotary
'Cause
phone.
Long time ago, we used to put our finger in a number and turn it. I know you guys don't do that anymore. You're all about the push buttons.
Oh, I
That's
know,
all.
I know. And they probably have us on speed dial anyway.
A speed dial. There you go.
Yes.
That would be great if you have a
Yeah.
speed dial. So our number, which we said was 301-772-0080, is one way to reach us. But we like to talk about multiple ways of doing things. So another way would be...
You can reach us on the web. All you need to do is www.pgcps.org. You can view us on the web. You can also email us. Okay?
And I love emailing because emails, not only might we solve them, but we have students that solve problems with the email corner.
They do. So all you need to do is email us at COU@pgcps.org. All right? And that will be your email. Just send us a problem.
All right. And I have a challenge I want to throw out before we throw out our other challenges to everyone.
Sure.
My challenge is, no, you're not going to kick me under the table on this one. My first challenge is to, let's say, happy birthday to my partner over here. Happy birthday, Miss Shirey. I'm not going to sing because that would be a big problem for everybody. That's one of those things that make you go,
Thanks.
But let's see the challenge. Can we do some calculations and figure out how many candles we might put on Miss Shirey's cake? Would the cake burn us down or not?
I don't know.
Only kidding.
It would only burn a little bit.
Only a little bit.
Yes.
But why don't you tell us about the challenges we really can solve?
All right. Well, the challenge that you can solve today, of course, we have our lovely First in Math challenge. We have some cards for you today. Remembering that the cards with the 2 and the 3 dots are a little bit more difficult. Maybe. Well, we'd like you to try some of those out. We always get a call for card A, but we would like some people to try card D or C. So card A is 1682. Card B is 2744. Card C is 8549. Remember, that's a 9 because it's filled in. And card D is 5333.
So we like to remind you that first of all, you need to have the challenge solved before you call us. Second of all, I hope you wrote them down. Work on them while we're working on homework problems with our students. There are lots of strategies to help you solve the Challenge 24s. Also note, multiple strategies. There's more than one answer to each problem as well. I've only come across one in all my years using 24 challenge cards. One card that stumped me where I couldn't find more than one way to get 24 with just these 4 numbers. So most cards have more than one way. And so if you hear a student say, hey, I want to solve card B, doesn't mean, oh, they took my answer. It means, let's see how they got it. Maybe I got it another way.
That's right.
So what are we doing with the cards again? What do we have to do with the 4 numbers?
Oh, we have to take the 4 numbers and add them, subtract them, multiply, divide them, or a combination of any of those functions, and you can figure them out, call us with the answer. You have to use each number only once, though.
There we go. That's a key.
That's the only key.
Even when they double it, so we're going to, there's 2 4s here, so we do have to use the 2 4s. But on these cards, you have to use each number once.
Right.
And the answer you get, and I said answer, I didn't say sum or product because I don't know what calculation or computation you're going to do, but the answer you get you can use to assist you with the next part of the answer. And I always tell students the first thing you want to do is add the 4 numbers and see if you can get 24, because sometimes that's the simplest way to do it. So this is a 6. Here we have 8 and 2 is 10, 16, 17. So that one doesn't. So now we know we need to go and use some multiple steps. by adding and then multiplying or maybe dividing, whatever it is we need to do to get to that 24. All right, so 4 cards, you got the numbers copied, you're working on those. Our second challenge.
Okay, second challenge. Things that make you go,
So her age or how many candles we'll need. You never ask a lady her age. But how about this one? What are we going about?
Well, it says things that make you go, And I have the numbers 1, 4, 8, 9, and 25. 8 does not belong with the other numbers. Explain why. So we kind of told you the answer. You just have to figure out why.
Oh, and I love when we do that with our students. We're always asking them for the answer. We're telling you the answer is 8.
Yep, it does not belong with that group.
Tell
and
us
why.
why.
Oh, those are some, I love that problem. Some of my favorite kinds of
Absolutely.
numbers.
Absolutely. All right, so what else do we have going on?
Well, I brought a hundreds chart today.
Oh, I love hundreds charts because math people love patterns. We just love them. And
yes.
hundreds charts are filled with patterns.
Well, I want to talk today about a group of numbers that really scientists have not yet figured out what their pattern is.
Scientists have it?
Mathematicians have not yet figured out completely.
They're pretty bright people. Let's hear what you're talking about.
Yes, I wanted to talk about prime numbers compared to composite numbers today because I feel like that's something we don't normally talk about, and 5th graders really need to know that. Some really excellent information.
And I'm just going to slide that over and write up here the word prime and the word composite because knowing math vocabulary and understanding it is key to being able to solve math problems. So prime, I'm actually going to use the symbol just because I'm going to use a symbol.
Learn something new. Prime number.
Prime number. Do I have to put an S here?
I guess we
Maybe.
could.
And composite numbers. So tell me about prime and composite numbers.
Well, prime numbers are my favorite numbers in the whole world. They're just mysterious and they're wonderful. They're numbers where you can only get that number by multiplying the number itself times 1. There are no other ways to get that number.
Okay, so prime numbers have factors.
They have factors.
Again, we like to use this math vocabulary. Factors of itself
Itself and 1.
and 1. That's it.
That's it.
That's it. All right.
No
so-
other whole numbers
Which means
can
that there
multiply.
are 2 factors. That's it.
That's right.
All right. Do we know, based on your hundreds chart, do we know how many prime numbers are there? Or, that's something that I want to know.
Scientists don't really know how many prime numbers there are.
But between 1 and 100, we do.
We do, and we can use a really special, this special scientist, mathematician, developed a sieve. I don't know if you all know what a sieve is. Do you know what a sieve is?
SIEVE.
Yes, a sieve is kind of like a strainer, a colander. Like when you make spaghetti, you put the spaghetti in the water through the strainer, through the sieve, and the spaghetti stays in and the water comes out.
All right.
So you're separating. It's a sorter, it's a separator. And there was a very famous mathematician, his name is Eratosthenes. Ooh, I can't even pronounce his
Good,
name.
because I didn't understand who you
Ooh,
said.
Eratosthenes.
There we go.
Ooh, it's really hard to pronounce. Came up with a method of determining, at least for the first 100 numbers, which ones are prime and which ones are composite. So if prime numbers are numbers where it only has a factor of itself in 1, composite numbers must be all the rest.
Okay.
The ones that have lots of factors.
So
or
are we
more than
allowed to
2.
just say all the rest? Or I think we might need to say numbers
Numbers that have 3 or more factors.
that
It must have 3 or more.
have 3. I'm going to take Civ off here for the moment.
Okay.
Have 3 or more factors. All right. I like it. So if we come over here, I'm going to play the student or the devil here, and I'm going to say, well, 1. How about 1? That must be a prime number.
1? I don't know.
Well, 1's a factor and 1's a factor. Itself's a factor. Oh, but it's the same 1. Can we use that same 1 twice?
I don't think so.
We don't. Okay. So I was just playing around because we know that 1 is kind of unique.
It's very unique.
Just like when we learn our spelling rules and we learn our grammar rules, they always have those exceptions to the rule.
Exceptions to the rule. Yep.
Well, 1's an exception to the prime composite rule.
Right.
All right. So 1 is neither prime or composite.
Right. He's a special group. We'll talk about him later.
Should I X him or circle him or?
How about we just X him out for
X
right
him
now?
out.
Because
We're just going to X him because he's not. If we're looking at this 100 chart, I hope it's okay that I wrote on this.
Oh, yes.
Oh, because I could have put him in a little case here, but
No.
okay. So we're going to look at the hundreds chart and we're going to look at prime versus composite.
Yes.
Bum ba da bum. All right, prime versus composite, and since 1 is neither, We're X'd him out. So I'm going to use your definition, factors of itself and 1. Well, 2 only has, I'm going to go to my infamous Texas T.
The Texas T, I love it.
And 2 is very simple because we start with the first counting number,
Which is 1.
which is 1, and itself, which is 2.
then
And we're done.
We're done.
So it has the factor of 1 and itself. So it qualifies.
That's right. It is a prime
So
number.
2 is prime. So why don't we use 2 colors?
Okay.
How about, do you have a preference? I like blue.
Okay.
So I'll
let's
use blue for prime, and we'll use red for, I'll use blue for prime, and we'll use red for composite.
Okay.
All right, so I'm going to just kind of circle this in blue because it is prime. I'm going to circle the word prime in blue as well. Cool, I like it.
All right.
So let's go to our Texas T for number 3.
Number 3.
And I know that I always talk about mathematicians being efficient, and you might be thinking, Sternberg, writing a Texas T and doing all that, it's really not efficient. But we're demonstrating. So for demonstration purposes, and when your teacher says show your work, you want to show all of it. Certainly when we get the mental math in our heads, I know 2 is a prime number, I know 3 is a prime number, I know 4 is not a prime number, because I know its factors in my head. But we're going to map that out for you and show you what it looks like. So why don't you Texas T the 3?
All right. Well, I know. Let's start easy. 1 times 3 is 3. 2. You can't multiply 2
You
times
can't,
anything.
so we're going to write it anyway. So we see 1, 2, no number there. You can put an X or a dash.
That's right.
Next
So,
counting number's 3, you're done.
You're done. It has to be prime.
Excellent.
So 3 has to be a prime number.
So I'm holding the blue. I'll circle the 3. And we're going to move on. So I guess we're going to throw out that question because maybe someone will solve our problem before we do. And we'll put it in green down here because we want to know how many. Do we want to just know how many or do we want to know how many and which?
Well, how many would be a good question. But
How many
because they're on the phone. But we'll hopefully by the end of the show we can show them how many and which.
numbers from 1 to 100 are prime. We're going to go with how
prime.
many are prime. And if we know the answer to how many are prime,
Then you know how many
we
are
know how many
composite.
are composite as well. So let's move on to number 4. And I'll move to the Texas T for 4. So we need to clear our board. So again, the strategy of finding factors with a Texas T, yes. I'm sure Ms. Shirey also, both of us have them memorized. I know what they are for 4, but I want to go through the steps aloud. I'm going to do my thinking aloud so you can see it. Always start with 1 in itself. So we always start, whether prime or composite, it looks like this. My next counting number is 2. I know 2 times 2 is 4. So actually, this is another rule which I sometimes don't say enough out loud, but when you get to the next counting number, 1, 2, 3, on the other side, you know you're done. Or when you have 2 of the same factors, you're also done. Okay? So 2, and when we say the factors, we really don't have to say it twice.
No, you
So
just
the
say it
factors of 4 are 1, 2, and 4. 1 and itself, but another number. Our definition was numbers that have 3 factors or more, 1, 2, 3.
Yep.
You're circling on that one.
Okay, so
I'm gonna
4.
put it over here so they can see that.
Yep, 4 is composite. I circled it on my hundreds chart, and I like what you did before. I'm going to circle the word composite in red so we
All right,
just
so we're
remember.
matching, we have like a key, a table, a chart, a key that we need to read. We'll clear the board, and I'm going to move on to 5. Again with my T, I start with 1 and 5. You always start with the 1 and itself. Prime or composite, always start that way. My next counting number is 2. Well, I know that 2 times 2 I just did was 4, so obviously it is not 5.
Obviously not.
And my next counting number is 3. So 3 times 2 is going to be 6. So that's going to be too big, so it can't be 3 either. And certainly there's no number right next to, there's no consecutive number.
No.
Next to a number that's going to be able to multiply and be a factor. So 24, we know 23 is not a factor when I say the next consecutive, or 25 will never be a factor. If I said 36, 37 would never be a factor, 35 would never be a factor. Not even the next few numbers would not be factors, but that's the premise I'm going on right now. So 3 and 4 are not factors. There's our 5, so we're done. No one has a partner here.
Nope.
But 1 and 5, 2 factors, 1 in itself. I'm circling.
turn.
I'm circling. And speaking of turns, I think we might give a call a return.
Okay.
So why don't we do that?
Let's do that. But you're winning so far, I must say.
Are we having a contest?
I wonder if there's a pattern.
Oh, so now we're not just thinking about, come back here, how many numbers from 1 to 100 are prime. We also said we might want to know which ones they are. So if you figured out how many, you should know which they are. Now we also want to think about, is there a pattern
Right.
to the prime and composite? And she kind of used the word 1 jokingly, but are there more primes or composites from 1 to 100? So we have a lot to think about.
Being efficient, and I just know this is going to take a long time if we're not efficient. So we have to find a different way.
Excellent thought. Our next thought is going to go to Joseph, because he's
Okay.
on the line, and we're going to come back to these thoughts.
Joseph, are you there?
Yes, I
Hi,
am.
Joseph.
And Joseph's a regular.
He is.
He is.
I haven't been on the show in a while.
I am a regular.
Yes, he is. We like that,
Excellent.
Joseph.
Joseph, what school are you calling from?
Cherokee Lane,
Cherokee Lane. Excellent. What grade are you in?
5th grade.
5th grade. Okay.
So what kind of problem can we help you with? I'm trying to find the paper to write your name.
Long
I'll
division
write it.
again.
Say it again.
Long division.
Long
Oh,
division.
man.
All right, long division. We can do it. You did it last time. You can do it this time. What numbers are we working with?
3,279 divided by 81.
3,200. You did say a little faux pas in there with the word and, but I'm going to let you slide. 3,279 divided by how much?
81.
81. All right, so what's your strategy? Because we talked about this last time you called, and we hope that when you hear strategies, you start to kind of make them your own and own the strategies. So what, I'm going to make this a little closer here. All right, so what strategy do you use to attack this problem? What's the first thing you might do?
How many times is 81 going to the first number?
Okay, and one step before we do that is I like to get myself in what we call the ballpark. And even though we know expanded notation-wise, place value-wise, this is 3,000, we're really, if we look at just this 3, is it possible for 81 to go into one-digit 3? Will we have a digit above? No. So I'm going to put an X here because we know there will be no digit above the 3. If we look at that same line of reasoning, can we have an 81 go into the 32? Well, think about it. Which is bigger, 81 or 32?
81.
81. So we're not even going to have a digit here. We're going to have to go all the way over to our third digit. And that's where our first number will go in our quotient. The first number will go above the 7, and then we also know once we have a number here, every number needs a number above it. Okay?
Okay.
So that's a start. Now, you said how many 81s are in 3? We said none. How many 81s are in 32? How many 81s can we pull out of that, which are none? Or you can think the inverse, what number times 81, which we know is not going to get us there. So now we're looking at 300, or actually it's 3,279, but we're looking just here, 327. How many 8s, if we use this first digit to get us in the ballpark, what number times 8 gives us 32?
4.
4. That gives us a ballpark that we know we're going to be close to. So we're going to try this 4. If it doesn't work, if it's too big or too small, we'll make an adjustment. So next we know to multiply, and that's why I like to use this X here. 4 times 1 is?
4 times 1 equals 4.
And 4 times 8 is?
32.
Excellent. So there we go. Now we're going to do 327 minus 324. And I said this whole number because as a 5th grader you should be able to see. If we went from 24 to 27, how many more do we need? You can use the count up method, you can use the subtraction, but at this point you can see these digits are the same, so really it's 7 minus 4.
Which is 3?
Yeah, and that should be a real quick math computation to do. 327 minus 324, 24, 25, 26, 27 gets us right there. 3 is less than 81, so we know our 4 was actually right on target. And now we're going to bring down this next digit, which is a
9.
Excellent. Now, can we pull 81 out of 39? Are there any 81s in if you only have 39?
Add 0.
Okay, so you're thinking of the next step already, but let's make sure you listen to the question. If you only have 39, is 39 bigger or smaller than 81?
It is smaller.
It's smaller, so that obviously we can't pull 81 out of it. So yes, you need to remember to put a 0 here. 0 times any number is 0, so we're not even going to do that step. The question is, what does your teacher have you do with this number? Are you working on decimal answers, remainder answers, or fraction answers?
remainder. Answers.
So remainders, which I was hoping by 5th grade you say the decimal answer. Remainder just means we're going to take this 39, bring it up here as a remainder of 39. Now, how are you going to check this, Joseph?
We are going to multiply.
You're going to multiply. Miss Shirey, do you mind taking him through the checking of this problem?
Nope, we sure can.
So here's our quotient and our divisor, and let's see if we get to our dividend.
Go ahead, Joseph.
81 times 39.
Whoa,
Whoa, whoa.
come back. 81 times
40.
40, and then we're going to add the 39 at the end.
All right, so 81 times 40. Go ahead.
Okay, 1 times 0 equals 0.
Mm-hmm.
8 times 0 equals 0.
Mm-hmm.
Put your invisible 0.
That's right, because we're done with that one.
Then 4 times 1 equals 4.
Good.
4 times 8 equals 32.
Mm-hmm. Okay.
Add that.
Add them up. 0 plus 4.
Equals 0.
Yeah.
0 plus 4 equals 4.
Good.
2 and 0, 2 and 3. Then you have to add the remainder.
Yeah.
All right,
I'm just going
very
to say you're
good.
close, but not there yet.
That's right. You have to add, and the remainder is 39. It's going to squeak it in here. Okay, if I add the remainder, now what?
Then 9 plus 0 equals 9.
Uh-huh.
4 plus 3 equals 7.
Right.
2 plus 0 equals 2. And 3 plus 0 equals 3.
Now you're there, 3,279, 3,279. So
Very good.
excellent. Now, let me just say one thing while we have Joseph, the 5th grader, on the line. When we talk about, again, being efficient, certainly you need to do what your teacher tells you to do. If your teacher wants you to do this step right here with these zeros, but
Sure.
if you're putting zeros in a place and it's just really taking up a space, you can do this same problem by starting with 81 times 40, and we know that this 0 is going to take this first place, so go right here, and then you're just going to get 4 times 1 and 4 times 8, which is 3,240. Okay, so this is an extra step, and when you do this addition, it gives you an extra step of addition that you don't need. If your teacher wants you to show all the steps, then put them in there. But again, when you're multiplying by a number that has a 0 in it, you just need to remember to put that 0 as part of your product, as part of your sum there, as part of your partial product. Okay?
Okay, I also got another question.
Sure.
Can I do the challenge?
Challenge,
You have
yes.
it ready for us? Uh-oh. You have a solution ready for us?
I think so.
Oh, okay, which one? Which card? A, B, C, or D?
And did you get Joseph's name?
Yep,
In the treasure chest.
there it
I
is
think
already.
I'm going to do...
No, not I think I'm going to do. I think
D.
I've done.
Yeah.
Which
D.
one?
D.
D as in dog?
Mm-hmm.
Okay, 5, 3, 3, 3. Go ahead.
3 times 3 equals 9.
Okay.
And then 5 times 3 equals 15.
5 times 3 equals 15 all day, every day.
So
Then
you
you
started
add 9 to
numbers.
15.
Add 9 to 15, and what do you get?
24.
24. Very good. Excellent job, Joseph. That was a 3-dot problem. Okay.
Excellent. So,
All right.
Joseph, your name goes in again. And we asked this question last week. We're going to ask again. Joseph, your name is actually in 2 times. And it's only your name in there. What percentage, what chance do you have of your name being pulled out? 2 names. They're both yours.
100%.
You got it,
Very
Joseph.
good,
100%.
very good.
But we do have another caller on the line, so we're going to take that caller and we're going to drop your percentage a little bit, but that's a good thing because we want to get to more callers. So let's see who else we have on the line.
Hello, who is this?
Chabuzo.
Chabuzo.
Chabuzo, I love that name.
I think I know who this is. And what school are you calling from?
I keep touching
Yes.
it.
What school?
Yeah.
You're calling from my school, but what school is it?
Yeah.
I don't think
I'm
you
here.
can hear
saying,
me.
yeah. Can you hear Miss Shirey?
Yes.
All right, she said, what school do you go to?
Perrywood Elementary.
Okay, maybe you
Very
can hear Miss Shirey.
good. And-
Very good. She likes that. Why does she like that you go to Perrywood? Why is that? Why is she smiling from ear to ear?
Because she works there.
Yeah, because that's
right.
where she teaches. So tell me what grade you're in.
5th.
5th grade. And so there looks like no improprieties going on. I'm going to help you solve the problem.
Okay,
going on.
okay.
What problem can I help you with? And pronounce the name for me.
Chabuzo.
Chabuzo. Chabuzo. So tell me what and you're in 5th grade, so let's see what we got.
It says Matt's family is thinking about buying a family pass to the city pool.
I got it. Family pass. So I'm going to make a think bubble, and I'm going to put a swimming pass in there. I'm thinking about it. Bum, bum, bum. That's my think bubble. All right, and go ahead. Tell me about that pass.
The pass is $80 for a family of 4.
$80 for 4, yes. Tell me more.
Individual passes are $25 each.
Oh, $25. I'm going to use a PP here, which stands for per person.
Per person, okay.
Per person. So I've got $80 for 4 or $25 per person. What do you want to know?
How much money can Matt's family save by purchasing a family pass instead of 4 individual
I love this problem. You know why I love it? Because it's so real life. This is exactly, if you go to Six Flags or you go to any of those, what are they called? Amusement
parks, yeah.
Or swim clubs or anywhere. They have special price. Even the grocery store. If you buy 1 individually, it costs this much. If you buy this many, it's 2 for or 3 furs. So, yes, you have to be a consumer and do those calculations because sometimes it's not always a better deal.
Nope.
So let's look at this and figure it out. We know that it's $80 for 4 people. $25 per person means $25 for 1. Right? $25 for 1. Now, lots of ways to solve this. If you have a strategy, we can go with your strategy, or we can go with one of my thoughts. What would you like to do?
I'll go with your thought.
My thoughts. Sure. You're calling for help, so come with my thought. I like what we call function tables, input, output, or I like to look at the numbers. If this is the amount of money and this is persons or per person, 1 person is 25. I'm able to say that 2 people would cost how much?
50.
$50. And I would also know that 3 people cost
75.
Yep, just like a quarter. I'm adding quarters each time. And my 4th person would cost
100.
$100. What's more, 100 or 80?
100.
100's more for a family of 4, and let's even tell them how much more. So 100 minus 80 would be a difference of?
20.
$20. And I keep
good.
adding the word dollars each time because when you're talking about money or any numbers, attach labels so we know what we're referring to. So $20, hey, that buys you the family of 4 a pizza dinner one night.
That's right.
Excellent. So you're saving $20 by buying that pass. Excellent job. Thank you for calling. Count on us. Work on the challenge and give us a call back when you solve one, okay?
Okay.
Thank you.
All right, thanks for calling. I put his name in the box.
And you know what? I forgot to ask him. Are you still there? No.
He'll call back
I
if he
meant to
wants.
ask him what his chance is now, knowing that Joseph is in there 2 times, knowing
Chabuzo.
Chabuzo. I'm going to keep asking you that because I'm
That's
just
okay.
not getting it.
His name's in there.
Chabuzo's in there 1 time, so we have 3 names in there.
Right.
And if Joseph's 2 out of the 3 and Chabuzo's only 1 out of the 3, Joseph has a little bit of a better chance
Yeah.
right now.
Yeah.
And you know what we're going to also do right now?
What? Not yet. I heard we have one more caller. We can't keep them hanging, so we're going to take one more caller.
All right.
Hello, welcome to Count on Us. Hello? Is it Calvin?
Yeah.
Hi, Calvin. Welcome to Count on Us. What school are you calling from?
Cherokee Lane.
Cherokee Lane.
Cherokee.
Okay, and what grade are you in?
I got it.
Huh?
What grade are you in?
4th.
Okay, great. And how can we help you today?
I want to know what is 375 multiplied by 28.
375 times 28. Wow.
And what grade were you? Oh, you're in 4th grade. All right. They could be. They're working on these kind of multiplication problems.
Okay, so Kelvin, where would I start? Do you know? What place would I start?
5 times 8.
5 times 8 is?
40.
Right. So I leave my 0, regroup the 4. Then what do I multiply?
56.
Right. 7 times 8 is 56 plus 4.
60.
Good. Okay, leave my 0, regroup the 6. Now what do I do?
3 times 8 equals 24 plus 6 equals 30.
Right, very good, equals 30. Now what I would do, Calvin, is I will go back and I'll erase some of the work that I did so I don't get confused. All right, and then I like to cross them out as I go. So I'm crossing out the ones column because I already multiplied by the ones. Now let's move next door to the tens. If this isn't a 2, right, Calvin?
Yep.
What does that represent? What does it mean?
The second digit number.
Right, and if it's in the tens column and it's a 2, how much is it worth? Isn't it 20?
Yep.
Right, 28, so that's really a 20. So that's why I'm going to leave my 0 down here. Now let's get ready to multiply. You ready?
Yep.
2 times 5.
10.
Leave the 0, regroup the 1. 2 times 7.
14.
Plus 1.
15.
Very good. Regroup the 1. 2 times 3.
7.
6 plus 1 is 7. Okay. 2 times 3 was 6. Now, let's add it all up. 0 plus 0?
0.
Good. 0, 0.
0.
0 plus 5?
5.
And 7 plus 3?
10.
Good job. Count back 3. 1, 2, 3. Put my comma in. How do you pronounce that, Calvin?
10,500.
Very good. 10,500.
Can I do a challenge?
A challenge. You want to show them?
Yeah, let's just hold off one quick moment, Kelvin, and we want to show you also that another way of solving this multiplication problem would be to show the expanded notation, and you can take your 375, which is 300 plus 70 plus 5, times your 28, which is 20 plus 8, and when we multiply each of these out in our expanded notation, we get the same digits in each place value, and when we add them together, it comes to 10,500, which is the same answer. So another strategy, again, multiple strategies for solving problems. We like you to have a lot of things. We call it in your bag of tricks or in your repertoire, multiple ways of solving problems. All right.
Well, let's put his name in the treasure chest, and then we can go to a break. So I hope you will see us on the second half of Count on Us today. Remember to call, stay on the line if you're already on the line, and we'll see you in a bit.
Hi, I'm Cameron from Samuel Ogle Middle School. Today's email question is from Nicole at Benjamin Tasker. Nicole says, my problem is 98 hundredths times 7 and 3/10. I don't know where to put the decimal after I multiply. Help! Well, Nicole, first you do basic multiplication. You do 8 times 3, which equals 24. You drop your 4 and carry your 2. Next you do 3 times 9, which is 27, plus 2 is 29. You drop your 9 and carry your 2. Next you do 3 times 0, which is 0, plus 2 is 2. Next we move to the ones column. Now we do 7 times 8, which equals 56. You drop your 6 and carry your 5. Next we do 7 times 9. 7 times 9 is 63. Plus 5 is 68. You drop your 8 and carry your 6. Next we do 7 times 0, which equals 0. Plus 6 is 6. So now we add. For a placeholder, we add a 0. 4 plus 0 is 4. 9 plus 6 is 15. Drop your 5, carry your 1. Next we do 8 plus 2. 8 plus 2 is 10, plus 1 is 11. You drop your 1, you carry your 1. Next we do 1 plus 6. 1 plus 6 is 7. Now we look at the problem. We see that a decimal comes before 3 numbers in this problem, which means in the answer you bring the decimal over 3 places and you get an answer of 7 and 154 thousandths. Well, Nicole, I hope that was helpful. That was the email question of the day, and I'm Cameron Jenkins from Samuel Ogle. Bye.
Soccer. All across America, it's how kids get fit and have fun. Join us. Go to usyouthsoccer.org.
Welcome back to Count on Us, the second half of the elementary edition. I'm Miss Shirey.
I'm Miss Sternberg, and time has been flying quickly.
Yep, it
we
sure
want to
has.
remind you our number, 301-772-0080, flashing on the bottom of your screen, so you should never have a problem with that. We have challenges going on. Remember our 24 challenge. Remember our
Things that make you go,
and our prime and composite number challenge. That's our special challenge for
yes,
today
it
because we
is.
started working on that. So I wonder if we might, I'm not sure if we have a caller or we should be able to, we do have a caller.
We
Let's take
do.
our call and then see if we can get to any more prime and composite numbers.
Okay. Hello. I think they left us. Well, now we're back to the prime and composite.
We're back with
Okay.
prime and composite. So we're up to number 6, and I think it was your turn.
It was my turn, and now that we're up to number 6, I think we can learn to be a more efficient mathematician with number 6.
And that's what 100 charts help us do, too, with the
Right.
patterns.
And this is why, because you told me, well, you told each other that prime numbers have a factor of 1 in itself, and composite have 3 or more. And so I know that 6 is an even number, and all even numbers are divisible by 2.
Oh.
So I can start to think, well, 6 must be composite because it has to be divisible by 2, and 1 times 6 is 6. And just throwing that 2 in there, I don't even have to know what 2 is multiplied by.
But you do.
But you really do, I guess. But then we already have 3 factors.
Oh, so you're not going to just make a circle here, but you might make a long looking at pattern.
Yeah, because I know all the even numbers now the rest of the even numbers must be composite.
Well, that saves us from having to go through every digit by itself.
That's right.
Not only all the even numbers, but Is that every other? Okay, so all the even numbers except
2.
Except 2. So 2 is that
So,
exception we talked about.
I like your big circle idea. Then I don't have to go through and keep circling.
So can I take my blue one now and circle all these other numbers? Everything that's left?
I don't think so.
Oh, so something's not right there. So
No.
it's not that all even numbers are composite and all odd numbers are prime.
Right.
All right, because you're right. Now that I think about it, I'm looking. Now, 7, I know, 1 in itself, cannot do 2. 2 times 3 would be 6. So it can't do 2. It can't be an even number. And we just said 3 would be 6. So there's no number with this 7. But 9.
9 is an odd number.
9 is odd, but I know it's also a special odd number because it's one of those golden squares.
It's a square number.
It's a square number. So 9, again, I'm just going to go right back to what I know and what I'm comfortable with. 1 times 9 is 9. 2 times 9, there is no number because
It's
2
odd.
is even and 9 is odd. 3 times 9 is 3.
3 times 3 is 9.
And as soon as I have the same 2 digits, I know I'm done. So I have 1, 9, and 3 as factors. So that fits the rule that you get to circle.
Okay. Well, do you want to do 7?
I do. I was just going to say, let me do my 7, and now you're going to do your 9.
I'll do 9. Okay.
Now, 11, again, because I know the rules, and you can't divide it by 2, 3 is going to give me 9, and so 11's not going to work.
No, 11's
So
not gonna work.
11's my color, right?
Yep, you get 11.
I get 11, and I also get 13.
Mm-hmm.
Oh, 15.
15. Oh.
So we're going to, 15,
Well,
if we come
this
right
is
over
what-
here.
This is what 15 looks like. It's a rectangle.
Ah. Oh. Could you have 9 over there?
I have 9. Yes, I do. Here's 9.
Oh, so
9's
9's a
square.
rectangle also. Well, a square is a kind of a rectangle. So, so area can kind of come and play a little bit in here too.
Here's 7.
Oh. So now I look at it.
So prime, composite.
Prime. Let's hold on to that thought. That
Yeah.
is something worth thinking more about. I'm going to slide this off as we.
I'll take these back for. Oh, you want to keep them? Okay, because I have
I'm gonna
more.
put that
Okay.
back up. And I'm going to say, hey, Joseph, I hope you've been thinking about some of our challenges. And what are you trying to do? Get another homework problem solved?
It's actually a division problem, but with integers.
With
Integers. Integers, did you say?
No, integers.
in degrees.
In degree.
In degrees?
Mm-hmm.
Let's hear it.
That makes me go,
So let's hear what the problem is.
Line 38 divided by 10 line.
Oh, it's integers.
Oh,
It's negative numbers. And yes.
so you said degrees, and when we say degrees, we were thinking temperature degrees. When you say a line, you're talking about a line. What was it? Do you remember the number?
38.
You said line 38.
Yeah.
When we have this line here, we say it's an integer, which means it's a negative number. So when we show negative, we don't call it a line, we say negative 38. So if this was money, it means that you would owe $38. It's not that you have $38, it means you owe. You're kind of in deficit of $38. Or if you're talking temperature, actually, it's 38 degrees below 0. Okay, so maybe that's where you got the temperature from. So what was the other number?
10.
Negative 10 or just 10?
Yeah, negative 10.
Negative 10. So negative 38 divided by negative 10.
Okay, I'm trying to think the best way. I think they might. Is this the best way to do this? Because now I think we might be looking at really the patterns with dividing by negatives.
Right. How does the problem look, Joseph? Does it look like this?
Yes, it does.
Okay. Okay. All right. That's not
right.
the way that I would solve it.
Well, how would you want to see it?
I would, if you're talking about negative numbers and you're talking about remainders and things like that, I would think it would come as a fraction, but apparently not. So.
Yeah, is this in a problem solving or just written like this in the book or on the paper?
Problem solving.
Oh, so can you read us the whole problem? Because when we put a problem in context, it's easier to understand what the numbers mean and what they're looking for. So read the problem to us.
Negative Negative 38 divided by negative 10.
Okay, so there's no word problem with it.
That's what we thought you meant. Problem
No,
solving.
there's no word problem with it.
Okay, okay.
All right, well, if we took the negative away and we just said 38 divided by this way or that way, divided by 10. Okay, how many times does 10 go into 38? Do you know the answer to that?
3 times.
Okay, so 3 times, and then using remainders, I think we would need a decimal.
We would
here.
need a decimal. We need a decimal.
3 times 10 is 30. When we do the subtraction, what's 38 minus 30?
38 minus 30. Okay.
This should be a quick one. You get stuck on
8.
Exactly. Don't let the subtraction part stick you here. Now, 8 is less than 10, so we're on the right track. But this is the type of problem where we would add that decimal point and 2 zeros. Have you been doing that in your class?
Huh?
Have you added decimal points and zeros to problems yet? Can you see what I did? I put a decimal point because we want to get another digit here. And to do that, I'm not going to be able to get a whole number because I only have 8, but I need 10. All right, so the answer is going to be less than 1 because if I had 1 times 10 would be 10 and I only have 8. So it's less than 1. To be less than 1, we're going to move to decimal fractions, okay, because decimals and fractions are less than 1. Have you learned any of this stuff yet?
We did like a quick lesson, but...
A quick lesson. All right, well, let's keep looking at this. So when I add a decimal point to a problem, I'm allowed to add a decimal point and 2 zeros because I haven't changed the value yet. 38, it's still 38. Now all I'm saying is any numbers that come now in my quotient, once I move this decimal point up here, are going to be less than 1 whole. It's going to be, by putting the decimal point, we almost make it look like money. So here's 3 whole dollars, and everything else is change, which is less than $1. Right? 48 cents, 72 cents, 16 cents. It's all less than 1 whole dollar, right? Does that make sense, Joseph?
Yeah, a little bit.
A little bit. Well, which part? Tell me which part doesn't. Because I don't want to give you too much information that confuses you anymore. But again, I only have 8 left here. And the way you're doing it, you're going to say that it becomes a remainder of 8. If I take this decimal off, 3 with a remainder of 8 is the answer. And then we kind of put the negative here because you had negatives here.
No, positive. It would be positive.
We had the 2 negatives, and then 2 net. When you divide negatives by negative, you end up with a positive because there's a bunch of patterns that that we have. But it just you don't see it like this.
Yeah, you don't.
So
you need a decimal.
Yeah.
And if you haven't done decimals, Joseph, it's very difficult. So I mean, we can go through the answer with a decimal. How about we do that?
And we'll just give you the answer, but if you're saying you're not understanding it, it's because, you know, we're just doing this quick little lesson here. So if we, again, I'm going to put, we did this, 30, and we have an 8 here.
Yep.
Now we're going to add, we have no numbers left. So we're going to add zeros here, because every number has all these zeros on it. We don't put them there because it's what we call understood. We know that zeros don't change the value of the problem. I'm going to bring the 0 down, this decimal point up, and now it looks like we have 80. And how many 10s go into 80?
8.
Exactly. And now, what I was saying about the money, if you have 10 people and you had $8, 10 people and $8. 10 people, $8. Would every one of these 10 people get $1?
No.
No. If every one of these 10 people got $1, how much money would you have to have? 10 people, $1 each, how much money would you have to have?
The amount of money that I would have to have is...
$1 per person and 10 people. How much money would you have to have? If you have 1 person and they get $1, 2 people you would need $2. 3 people you would need $3. 10 people you would need
$10.
$10, exactly. If everyone's going to get $1, it's a what we call one-to-one correspondence. You need $10. Do you have $10?
No.
You only have $8. So is everyone going to get a whole dollar?
No.
No. Are they going to get more than a dollar or less than a dollar?
Less than a dollar.
Less than a dollar, exactly. Now, how do we figure out how much less than a dollar they get? How would you figure that out? You have $8, you have 10 people. How are you going to figure out how much money to give each person? You know you can't give them each a dollar. They're all going to get less than a dollar. That's one of those things that's making you go,
Yeah.
Right, okay, so we would divide, okay? So we're dividing the $8 by the 10 people. And we know everyone's not going to get a 1. So we know by adding a decimal point and 0, 0, we're looking and seeing our $8. We know we have no number above the 8, which means they're not going to get a whole dollar. We're going to bring our decimal point up here. Last week we were joking because I said put the decimal point 2 zeros, bring the decimal point up, and then forget about it. And we're going to forget about the 0 now that it's up there. And now we want to know what number times 10 is going to give you 8? 80.
8.
8. So here's our 8. 8 times 10 is?
8 times 10 equals 80.
There's our 80. 80 minus 80 is 0. Now we could bring the 0 down. How many 10s are in 0? Or we're just going to bring this 0 up. How much money? We have a decimal point and 80. How much money is that?
80 cents.
80 cents. Is that more than a dollar or less than a dollar?
That is less than a dollar.
Exactly. So every one of these 10 people will get 80 cents. So here, because we had 38, they're going to get $3.80 each. Okay, so we add the decimal point and extra zeros so that we can break up the whole number and show you the pieces, the parts, or how much of that whole, because we're not going to get a whole, we need less than a whole. So we have decimals to show us the number's not a whole number, it's less than 1. Okay?
Okay.
All right, so we got to 380, and when we divide a negative by a negative, we end up with a positive. Okay? So that's kind of the answer.
Yep, and instead of, you just don't put the dollar sign, Joseph. That's the only difference.
Right.
You can think of it like money, but in this case, the problem that you gave us did not have a dollar sign connected with it, so it's just 3 8/10 or 3 80/100. Okay, you can think of it either way. It just wouldn't be in dollars. Okay?
Okay.
All right, that's kind of tricky.
That is tricky.
Yeah.
And you said your teacher just did one lesson, so she's probably going to come back and revisit that type of a problem.
Right.
Okay?
At least you have a head start.
Is it okay if I do a
Oh, yes.
Sure. This is going to be the Joseph Show today. Let's see. Are you going to do the prime composite one, or are you going to do the things that make you go,
You're going to do this one?
I think I'm going to do the composite one.
Oh, okay. All right.
And actually, this kind of fits into some of the things you were talking about.
It kind of does.
Everything's kind of connected. Isn't
It all is.
All right, so tell us what you figured out on this hundreds chart, Joseph. Tell us some more information. And did we put his name in again?
Nope. I'll put his name in one more time. Okay, Joseph, what can you tell us?
Let's go to the next number. So we're looking at 15. That's our next number. Can you tell us if it's prime or composite and why?
It is composite because 1 and 15 are equal and 3 and 5 are equal.
Okay, so it has more than 2 factors. Very good. So 15, even though it's odd, it's composite. Very good.
Why don't you have him make him do a couple more?
All right, what about 17? How many ways can we get to 17?
17 is a prime number.
Why?
Because 1 times 7 equals 17, and there's nothing else that equals 17.
Right, 1 times 17. Okay, so that's blue.
Oh, yeah. Pay attention, Mr. Sturmer. And you know what's important about that also? You had that one memorized because, you know, again, you keep hearing me, I keep talking Texas T, and, you know, I want everyone to become an expert at it. But for me to have done a Texas T for 17, I would have just been writing 1 and 17, 2 and nothing, 3 and nothing, 4 and nothing, 5 and... You know, and this is a lot of waste of time where Joseph knew it was 17, so we're done. That helps.
Okay, so 17 is prime, yeah. What about 19?
19? That is a prime number.
Okay.
That's me. And I'm going to stop here for a moment. Joseph, count the blues for me. Can you tell the difference between the blue and the red on your screen?
Yeah,
All
I
right.
can.
Let's count the blues then. 1,
1, 2,
3,
4,
4, 5, 6, 7. So far we have 8 blues. How many reds you got going on?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
So it's 8 to 11 right now after 2 rows. So let's see what else happens. It seems like the question was, are there more prime or composite? I'm getting a feeling that there's going to be more composite because you've already circled all of these.
That's right.
I went to circle all of these and you told me I can't because some of these are not.
That's right.
So you get your whole column and you get some of mine.
That's right. I get some of yours.
So I'm going definitely with there's more composite than prime
we'll
numbers.
have to see how many
Well,
exactly.
Let's go back to this. This is very cool. And Joseph, you can hang on the line and help us through this if you'd like. But let's look here. You were going somewhere with these patterns. So tell me more. I like it.
Well, here's the number 7 in the shape of a rectangle. 1, 2, 3, 4, 5, 6. There's 7 cubes. The only way to make 7 is 1 times 7. 1 down.
Can't make
7
another
over.
row.
Nope.
Or another column.
Nope.
All right.
Not
so-
evenly.
Not
No.
evenly.
No.
And that's a key word. Evenly is good. But the 9 we could. The 15, again, even rows and columns.
That's right. Any number you can make 1 row of itself. That's the 1 times itself. But they're only the composite numbers you can make into different squares and different rectangles.
All right. So can you show me another one-y? 1 row or 1 column?
1 row, 1 column. Here's the number 5.
Okay. So I can't. If I broke this apart, I can put 2 and 2 and I have 1 extra, so it wouldn't be even. I could also turn it 1 row or 1 column. That gives us our commutative property, 1 times 5, 5 times 1, but it's still 1 and 5. All right, so how about another square or cube?
Well, here's some more.
Here's some more.
2
So
and
here's
3.
our, hey, let's look at our hundreds chart. Here's the 2, which we said was prime. Here's the 3, which we said was prime. Here's the 5, which, look how these are working.
Ah, here's 4.
4, which can break evenly into 2 groups of 2 or 2 times 2. I love it. You must
Here's
have
6.
a 6. Excellent, fitting right here. 2 columns of 3 or 3 columns of 2.
Now my 8, do we have 8? No, 8 must be lost. I can't find 8.
Oh, it's
But
lost.
here I can kind of make one with a 2 and a 6.
Oh, cool. 2 and a 6 makes 8. You didn't even have to tell us, or we wouldn't have never known.
Yeah, there you go.
And they all are rectangles or squares, which is a kind of rectangles. Here's that pretty 9, 3 and 3. That gives us a square, which is why that's called a square number. The 2 by 2, when you have the same number in a column and a row, when you have the same number in a column and a row, I'm just going to slide this over here for a moment.
I know.
I'm going to slide this back over here for another moment. And where else are you going?
Oh, there's 10. That's probably one of the
There's
last.
10.
Then it gets really large. Then I
And
have
then they start getting
25
big.
and different things.
Oh, 25. Look at 25 makes a square, so that's another one of those perfect squares.
Yeah.
So we can define perfect squares here while we define our math vocabulary. In that, any number that has the same number of rows and columns.
Right.
Excellent.
Makes a square.
All right, so we're not going to finish this now. We're going to give you a challenge and work on that. You can even call into the next show, which is coming on momentarily, and tell them how many prime and composite numbers are, because that moves into middle school as well.
That's right. That's right.
And we got a lot done, but mostly with Joseph, and we were so glad that he called, and we had a couple of callers.
But we have some other callers.
I'll hold this as you pick it out.
Okay. Okay.
And here we go. We're going to see, because we know who has the biggest chance of winning, but that doesn't always happen.
And it's Chibuzo from Perrywood.
So
congratulations.
Thank you for calling. And remember that the middle school pre-algebra version of Count on Us is coming on next from 5 to 6 o'clock. So start calling, start working on those prime and composite numbers. And for Miss Shari and myself, remember, you can always
count on us.
I'm Miss Frank, and I'm here with today's mini lesson on elapsed time. Elapsed time is when we find the difference between the start time and end time of an event. such as a game, a movie, a race. So I'm going to work on one-word problem with you and show you how I would solve it, and hopefully that will help you solve elapsed time problems in the future. So let's take a look at a problem. This problem is about my friend named Melanie. Melanie was going to the movies. She went to a movie that started at 10:30 a.m. So I'm going to go ahead and I'm going to write down the start time. 10:30 a.m. The movie was 3.5 hours, and we want to find out what time the movie finished. So what we're going to do is we're going to start with our start time, and then we're going to count on the hours first. When we're finished counting on the hours, we're going to then switch to counting on the minutes, which is often what I like to do with elapsed time. Start by counting on hours until we can't add on any more hours, and then we switch to minutes. So let's take a look, and we're going to use a clock. And I preset the clock to 10:30 so that we were ready to go. So let's take a look. We're going to start at 10:30, and we're going to add on 3 more hours, and then we'll worry about the minutes later. So we're starting at 10:30. 1 more hour gets us to 11:30. 1 more hour gets us to 12:30. And then our third and final hour brings us to 1:30. So let's go ahead and write that out on our problem, and that way we can see exactly what we just did on the clock. So we were starting at 10:30 a.m., and 1 more hour brought us to 11:30 a.m. So that's our first hour. Then we went from 11:30 a.m. to 12:30 p.m. and that was our second hour. Notice how I went from a.m. and p.m. because we were at 11:30 a.m. So the next hour would actually be 12:30 p.m. So be very careful to look at your a.m. and p.m. when you're working out a problem to see if somewhere in your problem you're switching between a.m. and p.m. Be very careful. We then went from 12:30 p.m. and we added on our third hour, and that brought us to 1:30 p.m. So there, we added on our 3 hours. We then need to go back and add on our half hour. Since an hour is 60 minutes, then a half hour is 30 minutes. So let's go back to our clock and add on 30 minutes. So we are here at 1:30 p.m. So let's count by 5s and add on our 30 minutes. 5, 10, 15, 20, 25. There's our 30 minutes, brings us to 2 o'clock. So let's show that on our problem. And we were at 1:30 p.m. And then our half hour brought us, to 2 o'clock p.m. And that was our 30 minutes. So let's take a look. We added on our 1, 2, 3 hours and 30 minutes, and that brought us to 2 o'clock p.m. So Melanie's movie ended at 2 o'clock p.m. So, whenever you're working on elapsed time, remember to start by counting on your hours until you can't add on hours anymore, and then switch to adding on your minutes. And that will hopefully help you find elapsed time in the future. If you don't have a clock at home like I had here, you can always draw one on a piece of paper. Start by drawing a circle, put your 12, your 6, your 3, and your 9, put the other hours in between, and then at least you'll have a visual that will hopefully help you add on your hours and your minutes for elapsed time. Thank you so much, and stay tuned for some more Count on Us. Have a great afternoon.
Across America, Service Learning is helping students improve their grades and their communities. Service Learning makes school exciting by connecting the classroom with community service projects.
Before Service Learning, I was just an ordinary student causing mischief during class. After Service Learning started, I got so involved into it, I started paying attention more, picked up my grades.
Okay, very good.
Service Learning absolutely drives academic success.
Working together, students solve real problems, build new skills, and apply their knowledge in a whole new way.
The great thing about Service Learning is it gives you this opportunity to go out into the world and do things hands-on.
Inside the classroom and out, Service Learning opens new doors and brings learning to life. Service Learning can make a difference in your school. Visit Learn and Serve America at learnandserve.gov to find out how.
Because how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
wheel.
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times length plus 2 times width.
Hey, welcome back to Count on Us. It's the secondary edition of the show. The second half, my name is Mr. Pugh. I'm here with my co-host.
I'm Mr. Belton. Welcome, boys and girls. Remember that the show airs on Comcast Channel 96, Verizon Channel 38. The phone number is 301-772-0080. You can catch us on Comcast or Verizon, and if you have neither, you can catch us on the web at www.pgcps.org.
Oh, remember COU at PGC.
COU?
Remember last week,
Thank you, sir.
our phone lines now, all the emails and questions came off an email site at www.cou@pgcps.org. Once again, we're here with homework help. We're here to help you out with anything. You know, we got Fast 2 coming up in 2 days for middle schoolers and high schoolers. We have MSA coming up pretty soon. HSA is coming up pretty soon. So we are here to help you with anything you might need. If there's a question or anything you want to talk about, that, you know, sometimes you and your parents have a little disagreement about what your teacher is teaching you, call us. Every Monday, every Wednesday from 5 to 6, we'll be here. All right. Now, as you all know, we watched the show from years past. We have a challenge for you guys. We have the Challenge 24, and I'm going to allow my co-host to explain it to you.
We have the 24 challenge. The idea is to produce a result of 24 using each number only one time in any combination of the 4 operations. You have 4 options here. Card A, you have 8754. Card B, you have 2 8s, 7 and 4. Card C, you have 9 6 2 1. Card D, you have 9 8 as well as 2 4s. Now the dots in the corner of the cards represent the difficulty level, 1 dot being the easiest, the 2 dots are intermediate, and the 3 dots are the most challenging. So if you believe you can find 24 on any one of the 4 cards, please do not hesitate to give us a call and let us know what you have.
I'm going to also give you an extra challenge today. I just watched a show a long time ago. It said things that make you go, And it says this: what shape has the greatest perimeter? Is it a square that has 4 centimeter sides, a pentagon that has 3 centimeter sides, a hexagon that has 2 centimeter sides, or an octagon that has 1 centimeter size? When you have your answer, you must give us an explanation why you selected which one. All right? And at the end of the show, we'll let you know if your answer made me go, aha. Not but aha.
Looks like we got our first caller, Mr.
We have a caller?
Yes, sir.
You want to do the first one? How about this? You do the talking, I do the writing?
There we go.
Sweet. Teamwork.
First call, are you there?
Hello?
Hello, is this Eric?
Yes.
Eric, what school do you attend?
Kettering Middle.
Kettering Middle School.
Oh, right. Hey, Kettering Middle. I'm ready to run the street from you, Eric. I'm at Ernest Just.
How can we help you this evening, Eric?
Change the fractions and percents.
Fractions and percents. Okay, Mr. Pugh is going to do the writing, Eric, and I'll walk you through the process. What's your question?
My question is 7/20 is equal to what percent?
7/20 is equal to what as a percent? Okay, what we want to do, Eric, is set up what we call a proportion. Proportion is 2 equivalent ratios. So our first ratio, which you gave us, or first fraction, was 7/20. We're going to equate that to another ratio or fraction that has a denominator of 100. Now the reason why we're going to do that, Eric, is because percents are expressed in terms of 100. The word percent means per 100. So, Eric, what do we do to 20 to get 100?
20 times 5.
20 times 5. Now, whatever operation we perform in our denominator, we must also do where?
To our numerator.
We must also do to our numerator to keep our fractions or ratios equivalent. Now, Eric, 7 times 5 is?
7 times 5 is 35.
35. When you have a fraction with a denominator of 100, your numerator is the percentage. So 35 over 100, or 35 out of 100, is equivalent or equal to 35%. Does that help you out, Eric?
Yes.
You have another question, or you want to try a challenge?
Can I? I have another one.
Okay.
And
We have some time.
It's changing the percent into fractions.
Changing the percent into a fraction?
Yes.
Okay. What's the percent that you have?
15%.
15%. When you convert a percent into a fraction, the first thing we want to do is write the percent over 100. So 15% be 15 over 100, or 15 out of 100. Now, Eric, what do we have to do to all fractions? All fractions must be what?
Equivalent.
Not equivalent. When we have a fraction, we must always, and Mr. Pugh is giving you a hint, we always want to simplify our fraction. Missing a couple letters there, Mr. Pugh, we'll make that happen. Okay. We have 15 out of 100. Now, Eric, any number that has either a 0 or a 5 in the ones place is divisible by what?
5.
5. So what we want to do is we want to divide 5 into both our numerator and our denominator. That's going to simplify our fraction.
Okay.
15 divided by 5 is 3. 100 divided by 5 is 20. So 15% as a fraction in simplest form is 3/20. Does that help you out?
Yes.
All right. You want to try a challenge or things that make you go, hmm?
I'll try a challenge.
Okay. Eric, we have another call behind you, so can you do us a favor and select your card? Which card do you want to try?
A.
Card A. Okay, you have 8, 7, 5, and 4. Do us a favor and try to work out the process and give us a call back, okay?
Okay.
All right, good job.
I like that strategy you use for Eric.
Okay.
Changing it to the fraction first.
Right.
I like that. Because percent is always based out of 100.
Yes, sir,
sometimes I know as a teacher we always go for like real quick solutions to divide the denominator.
Right.
The numerator. I like that.
More than one way to do a math problem.
Teamwork.
Always.
Partnership is always ready to go.
Next caller. Hello?
Caller, are you there?
Yes.
Hi, Samuel. How you doing?
I'm doing fine.
I know you wondering how I know your name, right?
Because I've called him.
You called so many times. And you must...
Sam, what school are you from, Sam? Pick your spirits up, Mr. P. You sound a little down and we got a Gwen Park Middle School
I love
call.
Gwen Park students.
Sam.
That's represented by county. Great job, Gwen Park Middle School. Great job. Who's your math teacher, Sam? And please don't tell me...
You know who it is, right? Mr. Pugh?
Mr. Button.
Oh,
my man.
All right. Sam, what are you all working on in class?
We've been working on the Pythagorean theorem.
All right.
Pythagorean theorem.
So you have a question for us tonight?
Yes, sir.
Yes, sir. I like that. What's your question, Sam?
If they give us 2 legs, one leg is equal to 12 and a half.
Okay, one leg is 12 and a half. Okay.
And the other leg is 6 and a half.
Leg is 6 and a half. Okay.
What is the hypotenuse?
Ooh.
Okay.
I like that word. Hypotenuse. Now, I'm asking you this question, Sam. I know you have an awesome teacher because he's standing here beside me, right? I won't tell him if you get this question wrong, okay? I won't tell him you get this question wrong, Sam. I'm going to ask you this question, Sam. Now, I know that in hypotenuse, they use certain letters, right, for legs and hypotenuse, right?
Yes, sir.
So, what letter are we solving for?
C.
C.
Square.
Can you give me the formula to find the side of a triangle for Pythagorean theorem?
A squared plus B squared equals C squared.
Oh my great, yeah, man! Don't tell him I said this. If you do tell him this, I'm gonna deny it. Your teacher's good, not awesome, but he's good. A squared plus B squared equals C squared. So, hypotenuse represented by which letter again, Sam?
What'd you say?
And the hypotenuse is represented by which letter?
C squared.
C. So I'm gonna say C. So therefore, I can substitute, right? A and B, correct?
Yes.
Does it matter which one is which?
Not really.
No. So I can say 12.5 squared plus 6 and 5/10 squared equal to C squared. Now, Sam, I can multiply really good. I know 12 times 12 is 144. But what's a half of 144 is what? 72 plus 144, I don't know. It's two heads. So I'm asking my partner here that multiply 12.5 times 12.5. And Mr. Buzz, what you get?
We have 156 and 25 hundredths.
156 and 25 hundredths.
That's 12.5 squared. 6.5 squared, we have 42 and 25 hundredths equals C squared.
All right, Sam. You see that on TV, Sam?
Yes, sir.
So now, I have to do what now? Add them together, correct?
Yes, sir.
So add them together as I add them together. I'm going to get 190 what? 8.5, correct?
Yes, sir.
Am I right, Sam? Check me out, Sam. I don't know. I'm doing it at the top of my head. 198 and 5/10, correct? Equals C squared. Am I correct, Sam?
Yes, sir.
So now, Sam, remember, I'm doing the top of my head. Now, my partner here doing it on the calculator, but he's not helping me out because he's trying to get me, because he wants, like, he's better than me, Sam. But, okay, so now, Sam, question for you. Am I solving for C or C squared?
You're starting with C squared.
Right, but what am I solving for? C or C squared?
Oh, you're solving for C.
I'm solving for C. So how can I give it that square? What's the inverse of square?
You have to find the square root.
Oh my gracious, Sam! You know what?
Awesome.
You're gonna tear the Fast 2 test apart. I can't wait to see your scores on this, Miss Sam. I want you to call us back after Fast 2 to tell us your scores too. But I'm gonna take the square root like you said, and you know, once we do the one side, we gotta do the other side, correct?
Yes, sir.
Now, Sam, I'm not gonna tell you, Sam. I know a long time ago when I was in school, like 5 years ago, when I was in high school 5 years ago. I just graduated high school, went straight to college in 1 year. So I was in high school 5 years ago, Sam, and I had to learn my squares. I know 14 times 14, I believe, is 196.
That is correct.
Right, Sam. Mr. Belton said I was right. I'm excited. Mr. Belton, yeah! Yeah! So I know 14 times 14, no, my perfect squares is 196. So I know my answer is going to be 14.2, 14.3, something around that time. So Mr. Belton, what's the final? That's the square root of 198 and 5/10.
We have 14 and 8 hundredths. And I want to see if Sam can round 14 and 8 hundredths to the nearest tenth. Because typically, when you are... Oh, Mr. Pugh stole your thunder, Sam.
I just knew Sam had it. I just knew Sam had it.
Stole your thunder, Sam.
Because Sam is awesome. So, Sam, did you see the final result, the final solution? Sam.
What'd you say?
Did you see the final answer?
Yes, sir.
How do you pronounce this mathematically, Sam?
14 and 1/10.
14 and 1/10. Very good job, Sam. Now, Sam, would you like to try a challenge?
Not yet.
Okay, here's what I want you to do, Sam. We have to take another call. I want you to give us a call back. So our next example, we'll do an example where they give you one leg and the hypotenuse.
And Sam, look at the TV screen. Select one of the 4 choices. Write it down and work it out. Remember, the number that's shaded in is a 9.
Correct. If it's not shaded, it's a 6.
That's a 6. That's a 9. So select A, B, C, D. And try and come up with the final answer of 24 of using any solution, any operation, all 4 digits. Okay, Samuel?
Okay.
Good job, Sam. Make sure you give us a call back.
Great question, Sam. I like that.
Sam leads the county in count on us phone calls. He calls every single show, it seems like, Mr. Pugh.
Man, you know what? And I bet you he must have an awesome grade in your class as well.
Oh, yeah.
One of the top kids. I like that. Learn from Sam. Top students of Prince George's County Public Schools.
Okay.
I think we have to return the call to Eric.
He has the 24 challenge.
He has his 24 challenge. Challenge, Eric. Challenge.
You got it, Eric? He chose card A, so we have 8, 7, 5, and 4. You have it, Eric?
Yes.
Hold on, Eric. Let me write it down first. I'm kind of slow
Now this
today,
is so your name goes in the hat twice,
I'm
Eric.
a little sick today, Eric, so you bear with me now, okay? I'm stuffed up, can't breathe. He has so much cologne on, I can't even smell right now.
We're going to see if you got it, Eric.
Go ahead, Eric, I'm ready.
Okay, so 5 plus 4 is 9.
5 plus 4, you said?
5 plus 4.
9.
Yes.
Okay.
And 9 plus 7 is 16.
9 plus 7 is 15, you said?
16.
17, you said?
16.
Oh, 16. Okay, I'm sorry.
He's trying to mess you up, Eric. Don't let him mess you up.
All right, Eric.
And then 16 plus 8 is 24.
Oh, 16 plus 8 is 20. Good job, Eric.
Good job, Eric.
Hey, go. Your name going in the box not once, but twice.
But twice
in the apple the box today. Good job, Eric. Yeah, not only did you answer 2 questions, you also answered a challenge question.
So make sure you stay tuned toward the end of the show, Eric, when we select our lucky winner. Right now, you have the highest probability because your name is in the hat or the box or the treasure chest twice.
Did he say the highest probability? Wow, he's dropping all the mathematical terms today. He's an awesome teacher, Mr. Belton. Thank you.
As are you, Mr. Pugh.
I try sometimes. So I'm going to go back to our second challenge of the day, just to remind you all, things that make you go, And we want you to know what shape has the greatest, the largest, the biggest perimeter. And it says, is it the first one, a square that has 4 centimeter size, a pentagon that has 3 centimeter size, a hexagon that has 2 centimeter size, or an octagon that has 1 centimeter size. All right, so things that make you go, And also, we're still doing our challenge 24, as you all know. So, therefore, continue to look and decide which letter A, B, C, or D, and do what Eric just did. And Eric called this, wrote the numbers down, hung up, called us back, had a perfect solution for us. Really quick on the air. Really quick.
Now,
keep working.
If you call back for A, you can't add all 4 numbers because that's what Eric just did. So you can still choose A, but you have to have a different method than the one that's already been presented.
And if you want to challenge yourselves out here, these little circles let you know the level of difficulty. So this is the highest level of difficulty right here, the 3 circles. So if you really want to challenge yourself, select D. Come on, mathematicians, select D. All right. So good. So Mr. Belton. So we have a little time. We'll talk about Pythagorean theorem. Sam is in your class.
So the example Sam posed was one where you have 2 legs given. So this example now we'll do one where you're given one of the legs as well as the hypotenuse. You can
I'm going to draw a picture. I'm going to try to draw
a right triangle.
A right triangle. Sometimes I have difficulty. Is that good?
That's good enough.
Oh, man, yeah.
So let's say our hypotenuse is 25. 25? Okay.
I like 25.
And let's say one of our legs is
16.
16.
And we're going to say this is X.
Okay. Now, one thing when I teach the Pythagorean theorem, I try to go beyond A squared plus B squared equals C squared, because if you look at your particular example, you chose X. And one thing I want to instill in my students is understand that conceptually the legs are adjacent to the right angle. So if they don't give you A or B, you're not confused as to what this value represents. This is still a leg because it is adjacent to the right angle. So setting up the theorem, we have X squared.
Okay, X squared
plus 16 squared equals 25 squared. So we have the sum of the squares of our legs equal to the square of our hypotenuse. Now we're going to rewrite the formula, but instead of rewriting 16 squared and 25 squared, we're going to evaluate those expressions. So we'll have X squared plus 16 squared, which is 256. And that's going to be equal to 25 squared, which is 625. Now, we want to solve for x.
I have a question, though, for you.
Yes, sir.
Why didn't you do anything with the x squared?
Well, we don't know what x is right now. That's what we're trying to find.
We solve it for x.
Yes, sir.
So I don't do anything with x squared, so it is unknown.
X is a variable which is used to represent unknown quantities.
Cause I always get that question all the time. What am I about to do with the x squared, Mr. Belton? I'm sorry.
Well, we're gonna solve for x.
All right, we're gonna solve for
x. So now, what we want to do is cancel out everything on the same side of the equation as x, which right now we have x squared. We have to cancel the square, which is our second step. But before we do that, we have to cancel this 256, which is being added. So what we want to do is tap into prior knowledge of solving equations and apply the inverse operation on both sides of our equation. So,
man, he said tap into prior knowledge of solving equations.
Because at this point in Pythagorean theorem, we've already covered one-step and two-step equations. We want the students to retain that information. I don't know about your students, Mr. Pugh. My students are experts at forgetting. So we want to make sure that we tap into that prior knowledge.
Well, my students
so that they bring that to the table.
My students invented the forgetting.
So we do the inverse of addition.
I've never been taught. Yes.
Which is subtraction. So we want to subtract 256 from both sides of our equation. When we do that, the 256 cancel, because that sum is 0. We can cancel that out. And then we get 625 minus 256. That gives us 369. Now at that point, we want to take the square root of 369. Well, excuse me, we want to take the square root of both sides of our equation. The square root of x squared is just x. The square root of 369 is 19.
19? I said 13?
Yes, sir.
So the two numbers be, you say 19?
19 and 2/10.
I'm lunching. 19 and 2/10?
Yes, sir.
Wow.
Now, one thing that I showed my students was typically when you're solving problems involving the Pythagorean theorem, typically they'll ask you to round your answer to the nearest 10th in the directions. However, you may get into a situation where you're asked to round to the nearest whole number, and there's a way that you can do that without the calculator. So we have 369. We want to round this to the nearest whole number. Now, obviously, we know that it's 19 and 2/10, and round it to the nearest whole number, that would be 19. But in the event you don't have a calculator, what you want to do is find the two perfect squares that 369 falls in between. That would be 19 squared, which is 361.
Can we write that down?
Yes, sir, please, if you would. 19 squared, 361, and 20 squared, which is 400. So in determining the square root of this value to the nearest whole number, you want to take the difference of 369 and 361, which would be 8, and compare that to the difference between 369 and 400, which would be 31. Since 369 is closer to 361 than it is to 400, this square root rounded to the nearest whole number would be 19. So just arming the students with another method for rounding to the nearest whole number, even in the event where they do not have a calculator.
Wow, I have two thoughts though, because I like this, and I remember when I used to teach Pythagorean theorem, I always try to relate it to the real world.
Yes, sir.
To the real world. Now, I'm not a good artist. I always give my kids questions like, Mr. Belton has to go up on his roof to clean his gutters. So therefore, he took out his ladder. His ladder was about 10 feet tall. He placed the ladder 12 feet away from his house and leaned it against the house. What's the total distance from the bottom of the ladder to the top of the ladder? And that's a real world solution.
Very great. Very great question.
So as the same, just what we just saw. But then also, I started questioning them like, what if they give you all three sides? If they say, hey, A is equal to, let's say, 36 meters. They say B is equal to 18 meters. And let's say C is equal to 45 meters. And they say, hey, question, is this a right triangle? Kids go, I don't know.
Yet
Mr.
another
Pugh,
good question.
Because Mr. Pugh, they gave us all three sides. I'm assuming so. But what do you know about right triangles, but about the Pythagorean theorem? And this is where our students, our kids, miss the point. Because we ask any student in Prince George's County, what's the Pythagorean theorem? Most of them will say, a squared plus b squared equals c squared. No, that's the formula. Because Pythagorean theorem is a special relationship that the sum of the leg squares equal to the hypotenuse squared. It's a relationship that the legs share with the hypotenuse. So to make a right triangle complete. So therefore, and what we know about right triangles is that C is always the longest part of the triangle. So therefore, I can say 36 squared plus 18 squared is equal to 45 squared. So when I finish this problem, we will. So what's 36 squared?
1,296 plus 324. And we want to know if that's equal to 2,025. That's the question.
So what's 1,296 plus 324?
That should give us 1,620.
So is 1,620 equal to 2,025? And my answer is no. So that would not be a right
not a right triangle.
That's not a right triangle. Because sometimes I ask you, are these measurements of a right triangle? You still follow the Pythagorean theorem because one side must equal to the other side because that's that special relationship for it to be true. If it's not true, like in this case, then no, it's not a right triangle. And Samuel, I see you call back for another challenge, but we're going to take your challenge after this break, okay? If you're still out there watching, you can also give us a call at 301-772-0080, and we'll see you after the break.
Stay on the line.
Hi, I'm James. I'm from Tilton Elementary School. I'm here today for the email question of the day. Mary needed to place a fence in her yard in order to keep her sheep in. If her yard is a rectangle with a length of 26 feet and a width of 20 feet, how much fencing will she need? Well, let's take a look. So first, I would draw a rectangle to represent her feet. Then I would draw 26 feet at one side and 26 feet on the opposite side. Then I would draw 20 feet at one and another side, and then 20 at the opposite side to represent the fencing. Since we're talking about perimeter, since I have to do perimeter, I have to add all the numbers. 26 plus 26 plus 20 plus 20. 6 plus 6 equals 12, so I'll put the 2 at the bottom and carry the 1. 2 plus 2 plus 2 plus 2 equals 8. Then I'll add the 1. That equals 92 feet. So the fencing of her yard will be 92 feet. That's it for the email question of the day. Stay tuned for some more on Count on Us.
At this moment, across the country, families are packing their bags for a getaway. And no matter where they end up, they'll all be home by dinner. Plan your own at playgolfamerica.com. From finding programs in your area to finding advice from PGA professionals, playgolfamerica.com has a way for you to get away. Visit today for details. playgolfamerica.com, your link to the game.
It's easy, Grandpa. Brush your teeth twice a day. Floss your teeth once a day. That's a way to fight decay, hey, hey. Brush and floss every day, hey, hey. Healthy smiles are the way, hey, hey, hey.
You can keep your smile for a lifetime, even a boomer-saurus like me.
Boomers, you gotta love them.
Welcome back back, ladies and gentlemen. We're back on the other half of our break to the secondary edition of Count on Us. My name is Mr. Belton, along with my co-host,
Mr. Pugh.
And we're ready to continue answering you all's questions, whether it relates to Fast 2, MSA, HSA, homework questions, 24 challenges. Sam, are you still on the line?
Yes.
Okay, Sam, you ready for us?
What did you say?
You ready for us?
Yes, sir.
All right, what do you have? Which card did you try, Sam?
A, B, C, or D?
Card D.
Card D as in David?
Yes.
That's right.
You sure you want to try this with Sam?
He's positive.
And you worked it out, right?
Yes, sir.
Okay, Sam. You know your teacher sitting beside me, right?
Sam, we're going to put your name in the hat twice if you get this 3 dot. What we got, Sam?
Oh, Sam, he's trying to make your probability high chances really high.
What we got, Sam?
4 times 9 is 36.
4 times 9. He already knows.
Bring it home, Sam.
He already knows, Sam.
Bring it home, Sam.
8 plus 4 is 12.
Yes, Sam.
And 36 minus 12 is 24.
Come on, Mr. Pugh. Where's your excitement? Come on now. Hey. Way to go, Sam.
Good job, Sam.
My man.
Gwynn Park Middle School.
Gwynn Park Middle School.
Not once, but twice.
Not
Knowing
once,
him,
but
he
twice.
Gonna put in there 3-4 times, Sam.
We're not going to do that. We're
going to
gonna
bring your gift back tomorrow.
We're going to keep it fair and honest. Way to go, Sam. But for the record, do know that he did try the D. That's the most difficult one you were explaining with the dots on the side, right?
Sam, who helped you? Oh, Sam.
He's off the line. He's gone.
He hung up on me when I asked that question. That means Sam.
I guess nobody helped him.
I don't know if it's authentic or not, Sam.
No, I don't think nobody helped him, Mr. Pugh. Okay.
Oh, man. You want to continue to talk about what we teaching in our classroom?
Pythagorean theorem. Now, we tied it up. We did a 2-leg example. We did a leg hypotenuse example. We did an example where we tried to confirm whether or not the dimensions form the right triangle. Now we're going to take it to the coordinate plane.
Oh, my goodness.
Take it to the coordinate plane.
Coordinate plane.
So the students realize that you can use the Pythagorean theorem to find the distance between 2 points. So if you want to give me a scale, maybe 5 units in each direction.
Oh, man. Oh. Whoop, boy, that looks pretty good. I'm excited. I'm happy. In the minds of the words, kids, you size, Mr. Pugh. You size.
So let's say we have. Okay, you're gonna label each axis for us.
I'm sorry.
Ladies and gentlemen, Mr. Pugh is very thorough. He's making sure he labels all of his
make
points.
sure the kids not confused.
Okay.
I'm ready.
Well, if you're gonna do that, you might as well put an X here
and
a Y there.
Oh, thank you.
Okay.
Teamwork.
Now let's say we have a call.
We want to pause. Put this on hold.
Elimination. Yeah, we can put it on hold.
Put it on hold. I'm gonna move that over because I love the way I did my drawing. So therefore, we're going on hold right quick.
All right. This is Gwynn Park Middle School. Carl, are you there?
Yes.
This is Antonio.
Yeah.
Antonio, for the record, what school do you attend?
You said what?
What school do you attend?
It's just middle school. Yeah.
No, that's not what he said. What school do you attend, Antonio?
Gwynn Park.
Gwynn Park Middle School?
Yes.
Gwynn Park Middle School. Welcome, Antonio. How can we help you this evening?
I have a question about elimination using addition and subtraction.
Elimination using addition and subtraction. You have a particular example in mind?
2x plus 5y equals -3.
Okay. 2x plus 5y.
2x plus 2y equals 6.
Okay. 2x plus 5y equals -3. And 2x plus 2y?
Yes.
Equals 6.
Yes.
Okay, in the elimination method, what you want to do is eliminate one of your variables to solve for the other variable. Once you do that, you want to plug in the result you get from the variable that you solve for to identify the unknown variable.
Can I tag team?
Yes, sir.
Now, Antonio, I know you don't know me, Antonio, but I'm going to help you out a little bit, okay? Now, I'm going to ask you a question. Look at the problem I set up on the board. Look at the TV screen. Which variable would it be easier to eliminate?
2x.
the 2x. So what I'm gonna do is I have to do something first. Is if I got to multiply one of these algebraic equations by -1, because I want to get the opposite for one of those, right?
Right.
So you want to do the first one or the second one?
Subtraction.
You want to, but you can't just subtract it. You got to first change the sign. Like I got to multiply like this bottom one by -1 first, right?
Right.
So now that gives me what? -2x minus 2y is equal to -6. So now I can subtract that from my first one because 2x minus 2y gives me what? 0, right?
Right.
What's 5y minus 2y? That gives me 3y, correct?
Yes.
What's -3 plus a -6? That gives me
-3.
Negative what?
-3.
Negative what? -3. When you subtracting adding two negative numbers, it gets bigger.
Okay.
As far as the number wise, but actual small in the value. But it gives me 6 plus 3 is 9. Keep my negative sign in front, right?
All right.
So what I do now? And I know Mr. Belton taught you this earlier because he used all the perfect vocabulary earlier, inverse and one-step, two-step equations, and when you do the one side to the other side, to conceptualize the equation. I love all that terminology to use. So look at my problem. What I do now?
Divide by 3.
Perfect.
Because 3 is your what?
My coefficient.
Very good.
Man, I like they got another key term he dropped down. Divide both sides by 3. So y is equal to what, Antonio?
-3.
Negative, and I'm tell you something, Antonio. I am so glad you kept that negative sign there, because most kids would have forgot and forgot to put the negative sign. But I'm glad you did, because the negative sign didn't go anywhere; it stayed there by itself. So y is equal to -3. So tell me, what's the next thing I can do to find out what x is?
You would redo the first equation.
By doing what?
2x plus 5y equals -3, and you would replace y with...
So basically, if Mr. Belton does not come to school tomorrow, you're going to have a what in the classroom?
You said what?
If Mr. Belton, your math teacher, does not come to school tomorrow, who will be your teacher?
You, Antonio. He's saying you're going to teach the class in my absence.
No, I'm not. I'm saying you're going to have a substitute teacher, right?
Right.
So basically, you're going to substitute the value for y inside the equation, right? So let's go back. You said you went through the first. You said 2x plus 5 times -3 equals -3. So that gives me 2x minus 15 equals -3. So once again, I'm going to add both sides by 15.
Okay.
That's to undo it. That's the inverse. Cancel out. That gives me 2x is equal to what? 12, correct?
Right.
And x equal to what, Antonio?
X equals 12. Oh, x equals 6.
Hey, there you go, Antonio.
Good job.
I know what you did. Just be patient. Tell your teacher to be patient. You making them look good right now. Just tell him to be patient. Make sure he have you a Snoopy snack tomorrow or something. X equals to 6, y is equal to -3, and you found both your solutions for that problem.
So as an ordered pair, Antonio, the final answer would be?
6 and -3.
6 -3. Very good job.
Boom. Did you want to try Challenge 24 today, Antonio?
Yes.
You made me work hard today. I'm on 5% in whatever you make in life because I helped you out today. All right.
Antonio,
Challenge 24.
You want the 24 or things that make you go,
24.
Okay, card
A
has been solved. Card D has been solved. Not that you can't choose those two, but you can't use the same methods.
C.
Card C. So you have 9, 6, 2, 1.
All right, here we go.
9, 6, 2, 1.
9 times 1.
9 times 1.
9, 6, 2, 1. 9 times 1 equals 9.
9.
Thank you, Antonio. I appreciate that. Yes.
Then 9 times 2.
I saw that coming. 18.
Thank you, sir.
Good job, Antonio. Your name going out not once but twice today.
Your name goes in the hat twice. Antonio, be sure to stay tuned because in about 15 minutes, we're going to be announcing our winner, and your name is in the hat twice. So stay tuned. You just might be our lucky winner. Good job.
I like talking to kids from Grand Park Middle School.
Yeah. All right.
There's some awesome kids throughout this whole county. Good job, Grand Park.
We have another caller. Caller, are you there?
Yes.
Hello, is this Rachel?
Yes.
How you doing, Rachel?
Good. How are you?
I'm fine. What school do you attend?
I go to Flowers High School.
I go to Flowers High School. Okay. How can we help you this evening?
Well, I went to Ernest, Mr. P.
Oh, my Lord! You went to Ernest! Oh! Ernest in the building! Ernest in the building! Yes, Rachel. Rachel, what's your last name?
You said what's your last name? Cash like
money.
money.
Oh, no, Rachel. No, Rachel. No, Rachel. No, Rachel. We don't want to put you out there. Okay, Rachel, how can we help you? See, when you're just, I let my man talk to you, Mr. Belton.
Okay, well, I have, with polygons, I'm trying to find the exterior angles of a polygon.
Exterior angle?
Yes, sir.
What type of polygon?
A pentagon.
Pentagon, okay.
Pentagon.
All right, I'm not a good artist. If you know Mr. P, you know I'm not a good artist.
Yeah.
Were you in my math class?
What'd you say?
Were you in my math class?
Yeah.
You were?
Yeah.
How long
was
ago?
one of yours, Mr. Pugh?
Mr. Pugh, I had you 2 years ago.
2 years ago. Okay.
2 years ago.
Okay, I'm so sorry. I can remember all the kids I taught. I'm sorry, yes. Does it look like that?
Yeah.
Okay, talk to me.
Okay, so the formula is telling me in parentheses that n minus 2.
N minus 2 in parentheses. So if you had me, you know that said the quantity of n minus 2. Go ahead.
Right, multiplied by
180.
Multiplied by what?
180.
180.
Divided by n.
Okay.
So I have to find the interior angle of this pentagon?
Did they give you any angles?
No, it didn't give me no angle.
Okay. Do they define n for you? I believe n is the number of sides in your figure.
Yes, sir.
Okay. How many sides do we have in a pentagon?
5.
Are you sure?
Ain't there 5?
Count it again.
Oh.
No, he's messing with you, Rachel. You have 5 sides. So
that's 5 sides, Rachel. Pentagon, 5 sides.
We're going to rewrite our formula, but instead of writing n, we can replace n with 5.
Yes.
So we'll keep our parentheses so that we know which operations to follow in terms of order of operations. Rachel, what's the first thing we do?
Parentheses first.
Oh,
parentheses
yeah.
first. Okay.
And I shouldn't have wrote it so big. Let me rewrite it really quickly, a little smaller.
Mr. Pugh's a little excited, Rachel. He has an Ernest Just caller.
Yes, I love my Ernest Just kids. Hi, Rachel. You made me feel so good today. And for all my people in TV land, yes, we do have high school kids as well. So what's 5 minus 2, Rachel?
3.
Okay. Times the quantity 180.
Okay, so 540.
540.
That's 540, not 540.
Okay, 540.
Yeah, 540.
540.
Not
Now,
540.
the last step is to divide 540, excuse me, Mr. Pugh.
Okay,
108.
100 what?
108.
108.
So that equals?
So each interior angle, Rachel, measures 108 degrees.
Great job, Rachel. Go, Rachel. Your name going in the cat too, Rachel, from Flowers.
We got to make sure we got you in the.
Did we help you out, Rachel?
Excuse me?
Did we help you out?
Yes. Thank you so much.
No, thank you
You're
so
very
much,
welcome.
Rachel.
Thank you for calling.
Have a great day, Rachel. Thank you for calling.
Rachel, did you want to try a challenge before you go? A 24 challenge?
Something to make you go,
Yes, I'll try it.
Which one?
C, 24. D. Stop, Mom. C.
China 24?
She said C.
You want C?
Yeah.
Now, you know, someone just solved C, so you can't do it the same way, okay?
D.
D? Okay, you can't do it the same way. So you want D. As in dog, David, dag, right? Here we go. So, D. Have you solved it already, Rachel? So the number you select is 9448. So how about this, Rachel? Write those 4 numbers down, 9448, and give us a call back when you solved it, okay?
Yes, sir.
Oh, I like yes, sir. Bye-bye.
Good manners.
Have a blessed day.
All right. We have another caller, Mr. Pugh. Phone line's picking up. Next caller, are you there?
Yes.
Is this Kyra?
Yes.
Did I pronounce your name correct?
Huh?
Did I pronounce your name correct?
Yes.
Okay. What school do you attend, Kyra?
Potomac Landing.
Potomac Landing.
Yeah,
okay.
Potomac Landing.
Here we go. How can we help you this evening, Kyra?
Huh?
How can we help you? What's your question?
I need help with the area and perimeter.
Area and perimeter. You have a particular shape?
Like the rectangular prism.
Rectangular prism.
Okay.
Okay. So that means you're talking about surface area.
Mhm.
Okay. Do you have a particular question where they're asking you for the surface area? Or you want us to work an example with you?
Working example.
Okay. So, Mr. Pugh, we have surface area of a rectangular prism. Now that formula is...
I know. First of all, we're talking about prism, we're talking about 3-dimensional figures, right?
Yes, sir.
So we have the length, we have a width, and we have a height. So I know that we're talking about each face. We're talking about surface area, we're talking about area of each face.
Mom, be quiet.
Yes, Mom. Okay, so we have a surface area. It's about the face of the area of each face. So it's 2 things I taught my kids. Mama, for you, Kai, I'm gonna be real short, okay? So we have 2L, 2 times length times width, plus 2 times height times width, plus 2 times length times width, okay?
Height.
I'm sorry, I had it twice. Height.
Mhm.
Equals surface area, big S, okay?
Okay.
So now, we didn't give you any dimensions yet, but I'm about to give you some in a few seconds, okay? So now let's say this is 4 centimeters. This is 3 centimeters. And I say this is 8 centimeters. All right? My length is 4, my width is 3, and my height is 8. So now I can substitute for each variable, okay?
Okay.
Now, the question is, why do I multiply each face by 2? That's the question. And I don't think we're going to have time to come back later on for your problem, Mr. Belton. Let me erase this. Now, question. Now, I don't know if your teacher taught you this or not, but all prisms are like, have a net. Has a net. So if I flatten this prism out, it will have 6 faces. I'm having a hard time with my earpiece. So I have a face here, 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 and a face here, and a face here. This is my bottom. This is my top. This is my side. I want too many faces. No, 1, 2, 3, 4, 5. That's it right here. Yeah, bottom, top, side, side, side. This is called a net. This is where my prism laid flat, and I got to find the area from each one. And you know, to find area of a rectangle is length times width. But since I have a top and bottom are equal, I can say 2 times length times width. So I have 2 sides plus 2 times width times height. Okay, since I have side again, I can say 2 times length times height. That's how I got this formula right here. So now I'm going to substitute my value for my variables. So I'm going to say 2 times 8 times 3 plus 2 times 8 times
4.
That's wrong. It's 4 right here. Times 3 plus 2 times 4 times 8 equals surface area. So I'm going to multiply really quickly. That's 24. 6 is 48. 32, 64 equals surface area. 64 plus 24 is 88. 88 plus that, I think it's 136.
136.
136 centimeters squared equals 730. And I know I kind of rushed you through it, Kyra. I'm so sorry. But
Okay.
if you understand how we got the formula, that's the main understanding. That's how you get the formula. And remember, this formula is for all 6 sides. This formula is for all 6 sides. Because sometimes they ask you a trick question. They might ask you like a question like, you get most questions like, yeah, wrap a Christmas present. And the box dimension is the height is here, the width is here, and the lift is there. So you wrap, and you wrap all sides of a Christmas present, which is good. They might say, hey, the box is so big, you cannot wrap the bottom. So you're not wrapping all 6 sides, you're only wrapping 5 sides. And this is why having a net sometimes is important, Kyra. Okay?
Okay.
Did you want to try a China 24?
Huh?
The 24 challenge, Kyra? Did you want to try a 24 challenge?
Yes.
Okay, which card? A, B, C, or D?
Which one you say, Kyra?
A.
A?
Card A, okay.
5, 7, 4, 8.
Now, we don't have any callers behind you, Kyra, so we're going to give you an opportunity to solve it right here on the air, okay?
So,
Kyra, do us a favor and turn your TV down.
Okay.
Okay, so you have 5, 7, 8, 4. Those are your 4 numbers.
5, 7, 8, 4.
Yes. Remember, you have to use each number 1 time. Any combination of the 4 operations, and you want to produce a result of 24.
I think it's 8 and 4.
Okay. 8 and 4. What you got?
What do you want to do with 8 and 4?
All right, Kyra, we're going to do this, Kyra. You keep working on it, okay? And you can email, shoot us an email in the email corner at cou@pgcps.org, okay?
Mm-hmm.
All right. Thank you, Kyra.
You're welcome.
Good job, Kyra.
Great job. Potomac Landing, you're awesome. So now, let's go ahead and shake it up. So I win a grand prize.
Now, you can do the drawing, because I know we have a lot of Gwen Park Middle School callers.
So go
we
ahead,
want
shake
to
it
make
up.
sure that we
Shake it up.
preserve the integrity of the show. We don't want any issues with.
Is Kyra still on the air?
Huh?
Bye, Kyra. Have a great day, Kyra.
See you later, Kyra.
Bye-bye. I have you shake it up.
Okay, here we go. We turn it upside down. We pass away. Here we go. What we got?
Samuel from Gwen Park Middle School. Great job, Samuel. Remember, every Monday and Wednesday from 4 to 6, you can always count on us. We're here to help you out with any questions you might have. Every Monday and Wednesday from 4 to 6, you can always count on us. Have a great afternoon.
Sam, we got your prize. Good job.
He's coming home with the bacon.